In this video, we're going to be looking over activity 9, the soda machine. So we're told that this specific machine is from PepsiCo, and it's used in restaurants in which containers of secret formula and containers of water are poured. Out of the machine comes cups of soda. All the fluid that goes into the machine comes out of the machine. So if it happens that 1 gallon of fluid, and that's a fluid of secret formula and water combined, go into the machine, then 1 gallon of soda pop comes out of the machine. Now for this specific machine, number 3099, it works this way. When you pour 3 containers of secret formula and 5 containers of water into the machine, you get 6 cups of soda pop out of the machine. Now for the first question, we're asked how many cups does 1 container of fluid hold? And to explain. To help us make sense of this problem, I've drawn some illustrations of the information they're giving us. So on the left side, we see that we have 3 containers of the secret formula. In the middle, we have 5 containers of water. And to the right, we have our result, which is 6 cups of soda pop. We want to know how many cups does 1 container of fluid hold. Then we have to consider the fact that between 3 containers of secret formula and 5 containers of water, we get a total of 8 containers. This means that the 8 containers together contain the same amount of fluid as the 6 cups. So if we want to know how many cups does 1 container of fluid hold, then we have to consider the fact that we have 3 containers of the secret formula and we have 6 containers of the water for a combined number of 8 containers. So the 8 containers together contain the same amount of fluid as 6 cups together, right? Because this is all that I'm putting in. So in return, they should all be in these cups. Next, we want to consider how much fluid is in 1 container. Well, if I was to pick a container, let's say for instance, this one right here, then I could say out of the total of 8, this one should have 1/8 of the total fluid. So if I'm saying that about the total fluid in the containers, notice that I could also say that about this. There is 1/8 of the fluid in 8 containers, and the same amount of 1/8 of fluid is also in 6 cups. But between the 6 cups, so we know there's 1/8 of fluid in those 6 cups, but we can say, well, there's 6 cups out of the total 8 fluids that we have. So we can conclude that we say we have that 1 container holds 6/8 cups of fluid. For this next question, we're asked how many containers of fluid does 1 cup hold? So we know that the containers together contain the same amount of fluid as 6 cups together. So the same fluid here is the same fluid over here. So the amount of fluid in 1 cup, now we're thinking about it from this way, is 1/6 or 1/6 of the fluid in the 6 cups. And just like before, since we have the same fluid on the right side and the same fluid on the left side, if I have that the amount of fluid in 1 cup is 1/6 of the fluid in 6 cups, then I can also say for the container, 1/6 of the fluid in 6 cups is the same amount as 1/6 of the fluid in 8 containers. Now we get that 1/6 of 8 is 8/6. So we can say 1 cup holds 8/6 containers of fluid. For this next problem, we're asked what fraction of each cup of soda is made up of the secret formula, and how would you know? So we have that every 8 containers has 3 containers of secret formula. So out of the total here, there's only 3 containers of the secret formula. So that means every fraction of the total 8 containers will contain the fraction of 3 containers of the secret formula. It's almost like saying any amount of soda pop that we get is always going to have 3/8 of the secret formula. And if we were to kind of break it down into a decimal or a percentage, we could say it has 37.5% of that secret formula. The rest of it should be what's left over from the mixture, which is the water. So for this next question, we're asked what fraction of each cup of soda is made up of water, and to explain. So we already know from the last question that one of these cups is a mixture of 2 things. It's a mixture of the secret formula and also some water. So let's point those things out. So each one of these cups has a mixture between both of them. But from the last problem, I figured out that out of the mixture, this cup should have 3/8 of the secret formula. But I'm still left with the idea of how much water is left over. So if you think about it, this is just a fraction or a decimal, right? So if I want to know what's left over, I could take the whole amount. So let's say in this case it's 1 and subtract it by 3/8. So this is the whole amount and I want to know what's left over. So if I was to do that, then I would get that this is 5/8. So I can make my conclusion that says a cup of, in this case, soda pop is 5/8 of water. So now we figured out what this question mark is. It's 5/8. And if you think about it for a second, when you mix your secret formula and you add your water, then you should come out to get a whole. So if we mix 3/8 plus 5/8, because these fractions have a common denominator of 8, then we can just add across. So 3 plus 5 is 8. And usually when we add fractions, we don't change the denominator. So we keep the 8 in the denominator, and 8 divided by 8 is 1, which implies the whole mixture in 1 cup of soda pop. So for this next problem, we're asked to complete this table. And for our convenience, I've left the illustration of the mixture between the secret formula and the water, and also the cups of water that it produces. So in this case, we have 8 containers of water. So that means that there is 8/5, right? 8/5 times as much water as in the first column. So there is 8/5 times as much secret formula as the first row. So that means we take our secret formula and multiply it by this 8/5. And that should give us our result for this cell. Now, very similarly, there are 8 containers of water. So there is 8/5 times as much water as in the first row. So that also means that there is 8/5 times as much soda pop as in the first row. And by multiplying these values, we'll get our result for this cell as well. Okay, so for the next column, we're given that we have now, we're starting off with 4 containers of secret formula. So that takes us to think that we need to consider the original values from our original machine. So on here, it was 5, and on here, it was 6. So now with that in mind, let's think about the containers of water first. So there are 4 containers of secret formula. So there is 4/3 times as much secret formula as in the first column. And similarly, there are 4 containers of secret formula. So there is 4/3 times as much secret formula as in the first row for the soda pop. So using this strategy, you can continue and finish the table for the rest of the values. And that is all.